All right, I'd like to start today by doing a little survey. So how many people here have a website or software as a service offering that they operate, that they actually run? Okay, a lot of hands going up, right? How many people have started this sort of weird DevOps transformation-y thing, and you read these, we need to learn to experiment. We need to learn to fail fast. We need to learn to recover quickly, all of those things. And then the website goes down, and they get the call from the manager. It's like, why'd the website go down? And then you're like, I thought we were doing DevOps. I thought it was okay to fail, right? How many people have had that conversation? Yeah, okay. And one last question. How many people do what they would call retrospectives? Like there's an incident, lots of hands, very good, okay. That's what we're gonna be talking about today, this idea of failure as success and how we think about failure and how we think about success. I wanna start off with a little bit of a thought experiment. One of the talks that I gave actually at the DevOps Con, I think it was last year, was talking about if we think of the different operational endeavors that humans are involved with, and we look to those other endeavors, what could we pull out that might be applicable to DevOps? So this is a talk that I gave that was asking, well, if we think of pilots as developers and air traffic controllers as operations people, what could we take from air traffic control, the National Airspace System, and apply to this idea of DevOps? There's a link there if you'd like to see the talk. But I want to start with a thought experiment sort of based on that idea. And it's a clip from JFK Airport in New York City. And before we listen to it, I want to tell you all, I'm going to ask you questions about this clip later, all right? So let's start our little thought experiment at JFK Airport.
Number 2 for the field, traffic on a 4-mile final with 3 on right, wind is 320, 22, clear line only 22 up. American 2 heavy, 22 up, you clear line? Clear line. You're long going to the done, Mark. Okay, I will double check it. American 2 heavy will just reset it. Should be coming back up in a little while. Right now, 32023 gets into 35. We can't land on we're breaking off the approach, and you don't get us to runway 31 right, we're going to declare emergency. All right, I'll pass it along, fly runway headed for now. Okay, declare emergency. No land 31 right, we're going to go left, and then turn around. American 2 heavy, just fly runway headed. The area. If you say you declare an emergency, 3 times I've told you that. 3 times we're declaring an emergency. Okay, I just want to verify. I know you told me if you didn't get 31 right, you would have to declare an emergency. Okay, understand. Fly runway headed. I got to get your turn. No. Schedule 62, a left on Alpha and monitor ground to the ramp. That's Alpha on the ground. I had in 180. You know, American 2 heavy, we are turning around to the left here and landing on 3-1. Remove everybody from our way. We've declared an emergency.
So that doesn't inspire a lot of confidence if you have to fly to New York, does it? But I have a question. Was this event a success or a failure? I want you to think about that for a second. Would you consider that successful or a failure? And what? Oh, did somebody ask, did they land the plane? That's a really good question. We're going to actually look at that a little bit. I'm not going to tell you whether or not they landed the plane. But come to think of it, what is success? Is success just the absence of failure, or is it actually something more? So that's what we're going to be talking about today. So this is a slide about me. I'm not going to go through all the details. I will say I'm on the Twitter sphere a lot, so if you'd like to tweet me about things that I talk about in this talk, that's totally awesome. We can continue the conversation there, or questions, whatever. The other thing that I would note is it's important to think about your own feelings with respect to failure as we go through this topic. Because, if you were raised where you get on the horse and then you fall off and then your parents say, well, maybe you should get back on the horse and just try again and you'll eventually get it, you're going to react to failure a lot differently than if your parents said, maybe you should go play the clarinet. Also, the environment that you're in, right? The company values about how they think about failure is also very important in discussing these topics. So I just want to put that out there to think about both you and your organization, how you think about failure, because that's going to impact how you think about this topic in general. There's been a lot of talks about postmortems and public postmortems. This is actually just a Google search from Chef. They, it turns out, hold all of their postmortems in public, and they hold them on a Google Hangout that you can join, and then they publish the results publicly. Now, a lot of you put your hands up for holding postmortems. What would it be like if you held them all on Skype and posted them publicly, right? It's kind of an interesting thing to think about. Have people heard of this idea of blameless postmortems? Blameless postmortems at all? Yeah, there's a little bit of discussion about this. We're going to talk. Does that seem weird to anyone, this idea of blameless? Don't worry, I won't blame you if it does. We'll talk about why it feels a little weird, but there's a lot of talk about that. And then finally, it's kind of funny. There's this kind of fetish, right, in Silicon Valley with failure, right? I like the developer up there, and he's all sad and looking plaintively at the city because of his failure, I guess, of his startup or something, right? So Silicon Valley. So today we're going to talk about the mindset, how you start thinking about failure as success. We're going to talk about the methods, the things that you would have to do in your organization to do that. And then the landmines. These are problems that people run into when they try to do this. So let's talk about the mindset. Now, we're talking about you're going to hear these words a lot, accident, retrospective, blame today, but really we're talking in some sense about this concept of safety. And it's a lot of actually what we're talking about comes from the safety sciences, the area of study that is about 80 years old, that deals with how we think about accidents and failure and how we improve systems to make them better. Now, you might say to yourself, hey, what does this have to do with technology? Right? This is safety sciences. They're talking about manufacturing or fire prevention or something like that. Who here has heard of Knight Capital? I see a couple hands going up. All right. So for those of you who don't know, Knight Capital was a high-frequency trading firm in New York. And they did a deployment on a Wednesday. And they opened up for trading at 9 a.m. on a Thursday. And at 45 minutes, 9:45, they suspended trading on their trading platform because it turns out for some reason they were losing about $140,000 a second for 45 minutes. When they were all done, they were about $460 million in the hole, and then on a Friday, they were out of business. So when we talk about technology, systems can move that quickly. We do a deployment on a Wednesday, we have a bad Thursday, and then there's not a company on Friday. Now, you might say to yourself, well, we're not doing high-frequency trading, so it doesn't really matter. We're never going to experience something like that. And I would point out this is an example of a PetNet feeder, the PetNet feeder. And it's this little thing that you can put a feeder in your house and then with your smartphone control when to feed your pets. And it was interesting because they had an outage in some minor difficulties with a third-party server. I'm assuming that means cloud, this cloudy thing. But they were starving people's pets. So it's kind of interesting how this stuff goes. So I want to talk about kind of the models and how we think about safety and failure over the years, because this is going to be applicable to how we think about it now. So originally, we thought about safety as sort of this idea of energy and barriers, right? So failure is a release of energy, often an uncontrolled release of energy, right? And so the thinking was, well, we can design safety into those systems, right? We can put more barriers, right? And in fact, if you want more safety, how do you get more safety? More barriers, right? Just build a bigger containment for the nuclear power plant or whatever. Bigger, more distance between stations in the factory. And this is really how we thought about systems post-World War II era manufacturing up until about the 80s. And then in the 80s, actually late 70s, something happened. 3 Mile Island. Now, for those of you who don't know, that's a nuclear power plant in Pennsylvania. And it's actually interesting. There were 3 accidents that changed our thinking about this. It was Chernobyl, Challenger, and 3 Mile Island. But it really started with 3 Mile Island. And what we realized in that accident is we fell victim to a couple things. First, we were building more complex systems than we had ever built before, right? Nuclear power plants are actually basically, if you look at the technology in the United States, they're basically nuclear submarine reactors that we made really big, and then we bolted a generator to them. So we had scaled these systems, made them very big, and they had become complex in the process, complex systems. The other thing is we didn't have direct observability. So it's not like we could go into the core temperature, go into the core and measure the temperature or measure the pressure because we would die. So we had all of these monitors around to do that for us. And there were conflicting monitors, among other things, in this situation. That sound familiar to any of the systems we operate? Right? We have monitors that tell us these things because we can't actually go to Amazon and see them. So we started thinking about, well, okay, maybe this is not the right way to think about the problem. So a sociologist named Charles Perrow came up with this idea of safety is impossible due to this idea of normal accidents. So he said, well, we can model things on 2 different axes. One is how linear the process is versus how complex it is. And then on the other axis, how tightly coupled those parts of our system are together. Are they loose? Is there slack in the system? Or are they really tightly coupled together? And his thesis was certain systems, the complex, tightly coupled ones, are going to have accidents. This is normal, and also you can't do anything about it. That's what he said. This is a graph from his book, and you can see linear on the bottom, loosely coupled on the bottom, tightly coupled on top, linear at the left, and complex on the right. And there's a bunch of interesting examples, or he has a bunch of interesting examples. You might think to yourself, where would you put your own organization in this chart? But he was mostly worried up here in the upper right-hand corner, nuclear power plants, nuclear weapons accidents. That's what worried him and kept him up at night. And he was saying these systems, the closer you get to over here, the more you're going to fail, and there's nothing you can do about it. But later, about 5-10 years after he published that, there was a group out of Berkeley that said, hey, we are observing some tightly coupled complex systems, and we're not seeing the accidents at the rate that you say we should see them. So what's going on there? And this is the beginning of the study of what they call high reliability organizations. They studied a bunch of different ones, but we're going to talk about the coolest one, which was the deck of aircraft carriers. And so what they did is they went to the deck of the aircraft carrier and they studied the whole system, planes landing, taking off, all of it. And they found a number of features of that system. First, constant active learning. So the idea that the people in that system are always learning about the system itself, but also new pieces of the system that get added or taken away. Decentralized active review. So that's the idea that if we're working in a system and I have someone next to me here and here, I can just kind of quickly check out of the corner of my eye what they're doing. And I can say, oh, you didn't set the hook right, or you forgot to set the hook, or whatever. So we can cross-check each other in real time in a real lightweight sort of way. Rank de-emphasized, oddly enough. They found out that the lowest person on the lowest ranked person on the deck of the carrier could say, we need to stop operations, we need to stop landings because something's wrong here, and they would stop the landings. They wouldn't ask why, or they wouldn't, yell at that person. They would do it. Crew rotation, so they rotate the crews through different jobs, which makes sense, right? Because you can't cross-check someone who's working next to you if you don't know what their job is, right? So they said, well, we should make sure that everybody knows what should be going on the deck of the ship. And then finally, this idea, and this is probably the most important one, success may be failure. And this is the idea that the plane could land, turn off, go to its parking spot, pilot gets out, everything's fine. We didn't bend a plane, we didn't bend the pilot, we didn't bend the ship, right? But everyone in that system was like, that was way too close to the edge. We didn't feel safe at all. We were thinking that something was going to fail. And it turned out to be fine, but we together as people don't feel good about that landing. And they would treat that as failure, even though if we were looking at it, we would say, well, it seems fine, right? All right, so to summarize, energy barriers, normal accidents, high reliability organizations. What are the big themes, right, the big shifts that we see? Static processes and repeated defenses, moving to this more active defenses and processes, right? So things that are moving with the system as the system changes, right? This idea of technical and engineering solutions. We can engineer safety into the system to more solutions inherent to people, the organization, and the way that we work together, right? So thinking about really the people in the organization. And if we apply this to technology, we kind of see the same transition, right? We used to invest tons in disaster recovery sites, right? Who's been an operations person that had to take care of the DR site, right? We used to spend a lot of time and money and effort doing that. And we moved to sort of simplifying, decomposing our systems. If you've ever coded COM or Corba, that was the whole idea behind that. Microservices. If we can decouple our systems, if we can and make them less complex where we can do that, that's a good thing, and we should try to do that. And now you see, though, kind of the forefront of thinking is this idea of drilled incident response, retrospectives, red teaming, and value streams. And we're going to talk about some of those, but you see a big shift in technology about how we sort of, quote unquote, become safer. All right, the methods. How do you do this? Injecting failure. People heard of Chaos Monkey? Netflix's Chaos Monkey. Yes? Yeah. I see a lot of hands going up. It's funny, you used to ask about this and people didn't know about it, and now a lot of people know about it, which is really cool. I won't go into the details. You should Google for it if you're not sure what it is, but they have a lot of different types of Chaos Monkeys that do different things and wreak havoc throughout Netflix's infrastructure, and it's why they have a pretty resilient system. I would note that some organizations are doing interesting things like human chaos monkeys. So what they will do is they will go up to someone and they'll say, I want your VPN token, I want your phone, and I want your laptop. And it's a Thursday, and go home, take a 4-day weekend, and then on Friday they do an incident drill. Because then they find who knows, they find out everything that that person knows and now is no longer there to help the team with. So they do chaos monkeys that way. It's also popular because that person gets a 4-day weekend. The other thing you see people doing is, if you work on a Mac, right, I'll take your Mac and give you a Windows laptop, and we'll run an incident, right? And the idea there is what do we store on our laptops? Our SSH keys, our GPG keys, all of our setup to really respond quickly to whatever's going on. And if I have to do that on a different platform, I might need some practice doing that. So they drill stuff like that as well. This idea of incident command and crews. So what we're finding in the industry is organizations are getting really good at sort of coming together to deal with a problem. And in fact, a lot of there's some consulting firms that teach tech companies this stuff, and it turns out they're all ex-firefighters, which is kind of interesting and odd. One of the things I would point out is that the industry is getting really good at like showing up and arriving to the fire and putting out the fire, but they're not so good at sort of dissolving the team in a coherent way. So the example I always give is the fire department. It would be like if your house is on fire, they come up to your house, they put the fire out, and then when they're done with that, they just take all their gear off, walk away, leave the truck there, leave the hoses there, right? But they don't do that, do they? They put the hoses away, they drive the truck back to the firehouse, they back the fire truck in as opposed to just driving it first so that for their next call, they're ready to go. Our industry still has some learning to do on how we can do that effectively. But this sort of idea of incident command and crews is a big part of it. Postmortems or blameless postmortems. I asked earlier if blameless feels weird. If it does, there's a reason for that. There's a researcher named Brené Brown who's done a bunch of research on this, and she says blame is a way to get rid of pain and discomfort. We're actually evolutionarily hardwired for blame. So blameless may seem a little weird. If you're curious about this, I think we're stuck with the term blameless, but there's a blog post I wrote on the distinction between blame-aware and blameless. So what do you do, right? How do you put these things together when you have an incident? Well, you need to debrief the actors. You need to gather the data because you have monitoring and metrics data, hopefully, and then create a timeline. And the real value in a good timeline like this is that it combines all of those things, right? We have the metrics up top. We've got what people did in the middle, and then what people said at the bottom there. And so when you do this, you can start to get these vertical lines here are called capital E events, and they're events in the particular incident that you can then reason about. But it's really important. A good high-quality timeline is worth a lot when you're doing postmortems like this. You need to have what I call retrospective ready infrastructure. So that's, it should cover the infrastructure. So in the plane example, it would be like the engines and the fuel and all of that kind of stuff. It needs to cover the environment. So that's things like airspeed and altitude and things like that. And then the operational aspect. So that's the pilots and the cockpit voice recorder. So what we're really trying to create here is this idea of a black box, but for our system that we're running and operating. Modern tools account for this. ChatOps, the reason it's so popular, if you know what ChatOps is, that's doing all of your operational stuff in a chat room. The reason people love it is because if they have an incident, they can just go back to the chat logs and see what people did and figure out how to react better. Teammate is a way to sort of look at a terminal with two people at the same time and then be able to sort of do co-pilot troubleshooting type stuff. And then there's modern incident response tools, PagerDuty, VictorOps that help facilitate this kind of stuff. If you haven't heard of ChatOps, this is a really good book by my friend Jason Hand. It's free from O'Reilly. I recommend you can download it there. It's a good read. All right. Failure as success, the landmines. These are the things that people run into when they try to do this. Landmine number one, only certain groups get to fail. So when I was a release engineer, or if you've been a QA engineer, right, we always used to get yelled at all the time if a release went wrong, right, when we were doing a release of the software. But developers, it's like they could write all the bugs they want, and that was okay, right? But the QA people and the release people and the operations people had to be perfect. That's kind of an anti-pattern that you see in these systems, right? That only certain people get to fail. This is a picture of a Toyota production plant, part of the Toyota production system. And those arrows there, it may be hard to see, but they're pointing to little cords that run along the plant. They're called andon cords. And in the Toyota production system, you can pull the cord and the line will stop and a manager will come and help you and ask you, hey, why'd you pull the line and how can I help? And if you can't solve the problem, then other people will come and help you, and the whole line will actually stop, and they'll help you solve your problem. There's an interesting story about this. GM actually opened a joint venture with Toyota, not far from where I live in San Francisco, actually, and they put andon cords on the line. It was all American workers, but it was had a lot of features of a Japanese plant. And so one of the workers pulled the andon cord, and the manager came over and said, "Why did you pull the cord?" What do you think he taught everyone that saw that interaction? Never pull the cord ever again, right? It's kind of backfired. So that's what I mean by only certain people can fail. Forgetting to dampen failure where possible. So you see a lot chaos days and things like that, right? It's not like people are going into data centers and yanking out cables, right? A lot of these organizations plan a chaos day. They do it on a Friday, or they schedule it and they let people know. Google, even though they may not let everybody know, the executives certainly know when they're going to do a chaos day, right? So that's one example of sort of dampening failure. When teams do these exercises, they can cry uncle and say, nope, this is bad, let's stop the exercise. Right? So it's just not kind of uncontained failure. Netflix, a lot of people talk about Chaos Monkey is automatically opt-in, but they still have a grace period where you can opt out of it, so you can make your system and service resilient while you're still building it, right? It's not automatically we throw you to the sharks of the Chaos Monkey, right? One of the other big landmines, only reviewing failure. So I'm going to show you a video here of something, right? So this plane looks kind of weird on the approach, and you'll see at the end it kind of does a weird thing, but you know, it sort of worked out, so that's fine, cool. All right. Then we kind of do this again, right? And we kind of push the system a little further maybe, and that one looks a little sketch, but you know, makes it down, so that's pretty cool. Everybody's fine, right? And then you see this pilot, which I think this was in Munich maybe, but gets himself in a bad situation. The wing actually scrapes the runway, and now it's not even on the runway anymore, so that's cool. But gets out of this situation, doesn't crash, so okay. This is a bright sunny day. This is in California. Everything looks lined up, and then you have this happening. So I doubt any of you want to be on any of those planes, but which one got the postmortem? That last one, right? We didn't look at any of the others. That's an example of what we call actually outcome bias. We see it all the time in postmortems. Another one that we see a lot is hindsight bias, right? And that's the bias of with knowledge of the present, past decisions are clearly poor. And it's a weird bias to have, right? Because it's like if we had a time machine, we could go back to ourselves and say, are you sure you want to type RM-RF? Like, are you really sure? And you're going to say, of course, because failure seems very implausible at this point in my life. Boop. And then you has a sad. One of my other favorite ones, I'll read this one. Correspondence bias is the undue emphasis on internal characteristics to explain someone else's behavior. This is the quintessential DevOps bias, right? You've got the development, I want change. You've got operations, I want stability. They're smiling, yay. There was a wall confusion, but they're smiling. And literally the second they have to talk to each other, they're frowny face, right? And you've got the developers saying, oh, those operations people, they don't want to take any changes. They just, want to run the system. And then you've got the operations people that are like, oh, these developers, because they're developers, they want to push code all the time. I hate them, right? So this idea that we ascribe values to people just because of the role that they're in, right? So we are awash in a sea of biases. The human brain is. There's one that's really my favorite. It's the Ikea Effect. And the Ikea Effect is you tend to place more value on something you built than on something someone else built. So you could have this really crappy Ikea piece of furniture but you put it together, so you love it with all of your heart, even though there's this nicer piece of furniture over here. Okay, so this is probably one of the biggest problems that I see with retrospectives is deprioritizing sort of retrospectives in the entire learning process. So how many people have had something like this, right? There's an incident on a Wednesday, and it's like a 4-hour incident, and you fix it, so that's cool. But you have to kind of Band-Aid it. And then you say, okay, well, we're going to do the postmortem on Friday, okay? Friday rolls around, and that Band-Aid that you put on Wednesday breaks. So now you have a 6-hour incident. So you're fixing that, and then at the end of Friday, you're like, screw this, we're going to the bar. We're going to get a beer. We're not going to do a retrospective today. But we'll do it on Monday. So go have a weekend, come back, we'll do it on Monday. Well, then on Monday, it turns out that Sally, who was the incident commander for the incident, she's on vacation. Okay, we'll do it next week when Sally gets back. So next Monday rolls around, oh, it's All Hands Day. So we'll do it on Friday. And suddenly, this retrospective for this event, you're holding it 2, 3, 4 weeks after the incident. And I can tell you, those retrospectives are totally garbage. Our human biases are going to fill in the details that are missing, and we're going to lose all of the rich context that we had for what we did that will help us get better. I actually have some questions back to our thought experiment for you about that incident we heard. And I want see if you can answer these in your own head. What was the aircraft's call sign? What type of approach was the plane cleared for? To what runway? Or was that actually runways? What heading did the controller order the plane to fly? What radio frequency does the controller hand the plane off to, right? Now here's the thing. If you can't answer these, I would point out to you, this was just 20 minutes ago that we heard this. Just 20 minutes ago. And I told you when we started, I was going to ask you questions about it. So all of you should be getting 100% on this, right? But, this stuff is hard. So it's really important to sort of hold this stuff sooner rather than later, hold retrospectives. Quick question. Who felt this was difficult because they don't have any familiarity with aviation? So they thought it was kind of like unfair. Yeah, okay. I want to speak to that for a sec, because I get that a lot. Most of us have flown. So most of us understand, like I get on the plane, and then I fly somewhere, and then I get off the plane, and I'm where I want to be, right? But it turns out work like this happens in the cockpit, between controllers, all day, every day, all over the world. It is a messier process than we often think about. And we can bring this into retrospectives. How many of us have gone in and maybe we're a developer and we say, that incident was caused by those database people. They screwed it up. I know how databases work, and they screwed up clearly somehow. Or I know not even if you're not blaming them, you could say, I know the problem is in the database, right? So the point that I want to make is a lot of these systems are a lot more complex. There's this idea of work is imagined versus work is performed, right? There's a lot more work going on, and a lot of times we think we know how it should work, but it turns out the details are a lot messier. A couple last ideas I want to close with. This is something called the Rasmussen Triangle. The researcher who came up with this did a bunch of work on, he was a safety sciences researcher, did a bunch of work on 3 Mile Island. And he came up with this triangle. There are of course, three parts to the triangle, three boundaries. On the upper right-hand corner, you have the boundary of economic failure. So that's the boundary that it would be too expensive to do whatever we're doing if we went that way. And so we wouldn't do it because it would be too expensive. Lower edge is the boundary of unacceptable workload. So that's the idea that we're all humans, and humans are lazy. I don't mean that as an insult. We're hardwired to get the most bang for the buck in terms of glucose in our brains and the work that we do. So we're inherently sort of lazy. And then, of course, that third edge is boundary of functionally acceptable performance or acceptable risk. And as we go over that boundary, what happens? We have an accident or an incident, right? All right, so there are these things called pressure gradients. And usually it's a business function or a government function, right? We want cheaper, better, faster in one direction, right? We want the maximum work for least effort. And so the cheaper, better, faster usually comes from high up management, right? And we're on the floor doing all the work. And where are those two pressure gradients pushing us towards? What are we happily marching towards? Which boundary, right? The accident boundary. So a lot of times, this is drawn with a dotted line. And organizations that are really good at pulling these systems back across and not having accidents that customers notice or incidents that customers notice are really good at sensing that boundary. So they are able to sort of see where when they're getting close and kind of crossing that dotted line. And so this is called the discretionary space. And the idea here is that you want to explore the discretionary space in it as a team as much as possible. Because the idea is that you want to be able to know when you're get really good at detecting when you're getting really close to that boundary of an incident or an accident. And then be able to go, hey, we need to slow down. Maybe we need to relook at our plan for whatever we're doing, or get ready to pull the system back across the boundary if it happens to go over into failure. One of the last landmines, relying on human error and blame. All right, so who heard of this Amazon outage? The S3 outage? Yeah, kind of affected a lot of people. If you read that postmortem, I would note, it's a fascinating postmortem, it's not even that long, the public one. You won't read the phrase human error once, even though the incident was caused by an engineer typing a command with incorrect arguments. So I would point, and bravo to Amazon for not using that term human error. So I would point out, what Amazon learned in this is things like operational tools with no input sanity checks, right? So a lot of their other tools didn't have any check on the values that were being passed to them by humans. They didn't have a -- I really want to take S3 down option, right? So they've started adding those to the tools they use. The service health dashboard's real dependencies. It turns out the service health dashboard in AWS went down because guess what? It's based on S3. Oops, they didn't know that. The index subsystem had grown and didn't have sufficient partitioning. So they learned that they need to actually look at when they do repartitionings of S3, but they had never dealt with that or thought about it in the east region of AWS. And then finally, this is kind of amazing, the indexing subsystem had not been fully restarted for years, right? And that was part of this problem. So if Amazon had just called this human error and then fired that engineer, they would have never learned critical details, not only about their system, but how they operate their system, right? All right, so what are the takeaways from all of this? Takeaway number one, the key to reframing failure is to stop thinking about incidents as events that went wrong and start thinking about incidents in terms of how you respond to them, how your team responds to them. Another way to think about this is an incident immune system, right? The more you use it, the better it gets, just like our immune systems, right? Takeaway number two, to make this practical, your operations and infrastructure need to be retrospective ready. And we sort of talked about what that means. But you really need to be prepared to take all of the data that you have in your system into a retrospective context. And then finally, the only thing that we directly control in the complex environments that we operate in is our reactions, right? We don't directly control complex systems. That's not how things work. All right, thank you.